lithium ion battery and battery management system for electric vehicle applications. So first we see about um, okay. So first we see about the on-road conditions, like what is our present scenario in our vehicle in on roads, and why we are why the transition is happening from our internal combustion engine vehicle to electric vehicles. So this is completely we are going to see about what's happening in our India. This is we are first the first portion we are going to cover this one. So the first we see about what is the present scenario of vehicles on our Indian roads. So basically, the vehicle on Indian roads are estimated. It's based on two-wheeler, three-wheeler, and four-wheelers. So four-wheelers we can classify into economic four-wheelers and premium four-wheelers. And apart from these, large vehicles like buses, large good vehicles trucks. So these are all coming under the large goods vehicles, we can say that. So from these all the vehicles, you can see nearly 79 percentage of the total number of vehicles are two wheelers. So in our India, most of the vehicles are two wheelers, and the next stage is you can see the three wheelers and economy four wheelers. So three wheelers we are not added the here. We can say like a passenger goods vehicle, tempos. So these are all covered in three wheelers, and economy four wheelers you can see that 12 percentage of the total number of vehicles. So it should be the cost is less than 1 million. If it is higher than 1 million means only 2 percentage. So if you are coming to the point, buses and large goods means is only 3 percentage of the total number of vehicles. So from these all the vehicles, like what we are facing presently, so these all this much vehicles is we are it's in on road, we can see in presently in our India. So what's happening, why the EV is needed, the basically what is emitting these vehicles. So typically these typical passenger vehicle emits about 4.6 metric ton of carbon dioxide per year. So everyone knows what is carbon dioxide. So it's a carbon dioxide is the result of combustion of organic materials or fossil fuels such as petroleum, coal, and natural gas. So and also many of our daily lives require the use of such combustion, um, like basic electricity, heating, cooling our homes, as well as driving our gasoline vehicles. So burning of these gasoline and diesel releases carbon dioxide. It's called as a greenhouse gas into the atmosphere. So the buildup of carbon dioxide, and also not only carbon dioxide and other greenhouse gases like nitrous oxide, HFC, and these are all is causing the earth atmosphere to warm, so resulting in changes to the climate. And we can see these things are day to day life we are presently we can see. So what is the solution, how we can the main problem we are facing, carbon dioxide emission. So this is our the initiation why the EV came into the India. This is the major initiation how we can reduce the pollution. So therefore, to rectify these problems or issues, the electric vehicle or an obvious move for future transport. An EV can reduce the emissions uh, that contribute to, maybe we can say, climate change, improving the public health, and reducing the ecological damage. And also one more important point, if in case if you are charging the EV using renewable energy such as solar or wind, means it also minimize these emissions even more. So in these EVs, electric vehicles, electric vehicles are basically powered by the rechargeable batteries. So everyone knows. So that's presently the hot topic in our India. So rechargeable batteries we can call as the there are a lot of batteries are there. So what's the present hot topic is lithium ion battery, because so that is very much practically adaptable and practically provable in electric vehicle. It should be and also it should be in running also. So therefore everyone using the lithium ion battery in EVs. And it's a most essential device in electric vehicle, because of without batteries you can't run the electric vehicle. So for example, there is one storage device is there. So not only battery, we are using different energy storage devices. For example, you can see the fuel cell, supercapacitor. So every all the energy storage devices are we can use it to run the vehicle. But why particularly we are looking battery means, if you are comparing with the all the concerns, for example, it's based on their specification, it's based on their application requirement, and we can say called as the space requirement, everything. The this particular this battery is adaptable to EV. That's why we are moving to the EV. Okay, but few applications, sometimes you need the supercapacitor. But somewhere, for example, telecommunication, okay, not EV. If you are moving into telecommunication, means in telecommunications there we need the fuel cell. So there is some it's based on the application requirement, what application is required, what is the power, what is the energy, what is the safety. So everywhere, so all the concerns it will be include to choose the energy storage device. And the next, we see about from these concerns, the how the what are the features or advantages of the electric vehicles. The first point, we already seen there is no need of conventional fuel. So conventional fuel means like gasoline, petrol, diesel. So these are all not required. And the next, cheaper to maintain, and it's more eco-friendly, and lower carbon footprint, because of due to very less noise pollution. uh, so that is a lower carbon footprint, and it's a smoother ride. So you can see the in this table you can see here, this is like a the basic some differentiation we gave here. So for example, the gasoline vehicle, it's like a produce the pollution but there is no emissions. And what is the utility of the electric vehicles are utility companies, that is vehicle OEMs. And but gasolines are like it's like a petroleum operated export countries. And like the electric vehicle is how much mileage is giving, and the gasoline how much mileage you are getting, and what is the time to charging of the electric, what is the time to filling the petrol or diesel. So there is some merits also is it, some demerits also is there. But presently there are a lot of researches going on how to improvise the in electrochemistry level, in electrical level, mechanical level, thermal level, how we can improvise, and how we can like better than gasoline or better than internal combustion engine vehicle. In all the aspects we are working on it. Okay, so and second, you can see this like outline picture of the car. So just the basic the transition you can see here. um, so here you can see the gasoline and EV important, a very important key components, or we can say the basically the key factors. It's differentiated by the colors for easier understanding. For example, you can see here the uh, like internal combustion engine vehicle, we are using the engine, combustion engine is powered by the petrol or some it's like a petrol or gas, somewhere it should be filled by the some uh, like some petrol or gas pump, like some like some petrol bunk like that. And but in you can see the in electric vehicle, so electric vehicle the main component is electric motor. The electric motor is powered by the rechargeable batteries, and these batteries are charged by the you can charge it in your household appliance, or otherwise you can charge it in common charging point. And this is like the major key components, it's called as a key component, because of there are a lot of components are there, but it's a very major key components when we are considered to design the when we are considered to design the electric vehicle. Next we see about, so what is the present scenario of electric vehicle charging in India. So now you can see everywhere in our India. So few, it started already the like the two wheelers. The first majorly our government they focused more two wheelers because of that is more it's there in our it's a in on road that is two wheelers only. It's more we are using on it. So we are driving on it. So they first they focused two wheelers how we can provide the transition from internal combustion engine vehicle to electric vehicle. Okay, so now you can see the started with the two wheeler and three wheeler also is there, and few four wheelers also you can see in our on road. Okay, so first the vehicles are came. The next the target is how we can implementing the charging point. Okay, so because of we have a common infrastructure to fill the petrol gas also, whatever the vehicle came. Okay, just they can fill what is the what you want, like petrol or gas or a like a diesel. So they will ask that that's a simple question and they will fill it, that's all. Okay, but EVs are not like that because of vehicle came, but each vehicle have a different specifications in terms of you can say the motor specification, battery specifications, everything is different. Okay, so if all the specifications are including if you are taking the two wheeler also, there are different companies are there and their own if each company have their own specifications. Okay, so if you want to charge that vehicle in common charging point without that knowledge, you can't do it. Okay, maybe if the government they're making the standard the motor rating standard old if they will provide the standard for some two wheelers means we can easily develop a charging point for separately for two wheeler, three wheeler, four wheelers. That is very easiest way we can do it. But another thing is now also is there charging point. Okay, maybe you can see in Delhi, Bangalore side you can see more is charging points are is there, but you can charge that vehicle that particular company vehicle only you can charge it. Okay, for example you can buy the Ether Energy vehicle means, so they will anyway they will provide the charger. Okay, that is called as a slow charger, slow like it's called as a slow charger. So you can using the charger in your home. Okay, maybe you can charge in the night time, you can charge your vehicle, and maybe on the daytime you can use it. Okay, but it's sometimes you have to like move suddenly you need to go for very longer distance means, so maybe somewhere the charging point also is there, but you can charge this vehicle, the Ether Energy vehicle you can charge only in the Ether Energy port only. Okay, if a Bajaj vehicle means the airport only you can charge it. Okay, because of the main reason is the spec is different, because of maybe they are using the Ether Energy, they are using the battery pack voltage is maybe 48 volt, but Bajaj maybe they will use 60 volt, so there is a difference is there. Okay, so this is the major we are facing the major problem now. So the government also presently initiated to how we can provide the free charging points, how we can regulate the rate also. Okay, because of we have some rate for petrol and diesel, but how we can rate for electric vehicle charging. Okay, and EV charging infrastructure, community charging stations. So investment by large fleet operator, and another technology, battery swapping technology. This is one more another technology. This is how what is the happening in battery swapping technology means you can swap your battery instead of charging. Okay, so there is a common charging this swapping station will be there in a particular somewhere some particular distances is there means you can swap your batteries here also. We have to consider the whether that battery pack will support our vehicle or not. Okay, but presently this battery swapping technology um, work is actually going on. So uh, what our government is doing means they are just uh, for they are just started with for only for two wheelers. So they are giving the common architecture for like all the battery packs. So they have a common battery packs, it's they are fixing for some voltage, and they are developing for some battery capacity, so that is a fixed. Okay, so their swapping station they are going to be fixed for two wheeler. So maybe these standards are the one by one it will become in near future. And the government initiative policies. So these are all like present scenario of what are the initiations in OEM, that is a vehicle OEM, OEMs, and what the government also initiated to the charging level or charging infrastructures in our India. Next we see about okay, so now we are going to see about battery powered vehicles. So next stage, we are one by one we are going to see about the battery and BMS. So here, what you can see here, okay, first when the battery powered vehicles came, okay, so it's very interesting story. In late 1918s and early 19, it's a golden period for EVs. Okay, so the EVs is not new for us. Okay, so it's already started. It already came before the internal combustion engine vehicles. Okay, but particularly that time it's operated by the lead acid battery. So everyone knows lead acid battery. So what's the main like a drawback of lead acid batteries? It should be very heavy weight. So batteries should be very heavy weight, means the vehicle also the weight will be increased. And the second, the short trip range. And the next is a long charging time. Compared with lithium ion battery, it takes a more time to charge a lead acid battery. And poor battery life, yes, definitely, because of, you can see, if you are buying the lead acid battery also, they will give the warranty. It's very less only, number of years also will be very less compared with the lithium ion battery. So that's a major problems in early days we are faced using the lead acid battery powered vehicles. And then after, by 1920, okay, the completely, particularly on the completely, the market is dominated by the IC, internal combustion engine vehicles. Because of that particular time, the diesel, petrol, it should be, we getting very easily, it should be very economical cost. So that's why these gasolines are provided very long range and a high horsepower. So that's why the completely the market adapted to the internal combustion engine vehicles. And after why the transition is happening means, it's not in 2017, nearly I can say in 1990. Okay, they started the transition because of the only reason is carbon emission. Okay, so there is that, it's not directly, it's not they came the battery powered vehicle. There is a small by small transition is happening. It's came first, it's first it's happening the hybrid, and like a full hybrid, and after that we came into the battery operated, complete battery operated vehicle. So the, like, step by step, some uh, uh, like uh, some tangents happening. And then 2017 we launched the we complete environmental concern and renewed the interest in EVs. This is 2017 we launched the vehicle, so that's why they mentioned the 2017. Okay, so these are all the history of the battery powered vehicles. And the next we see about types of electric vehicles. So how the transition is happening, it's not happening directly, we are not converting into the internal combustion engine to full EV. So it's happened by step only. So first you can see, this is our today, this is our conventional vehicle. Okay, so then first what happened, what is the first stage of implement means micro hybrid and mild hybrid. So micro and mild hybrid are equipped with an electric motor, but still uses an internal combustion engine to drive the train. So what's the primary role, then why we are using the motor? So what's the primary role of this motor is to just support the combustion engine. For example, I can say when starting or accelerating the vehicle. Okay, so this in turn further increases fuel efficiency and thus reduces the carbon dioxide emission. So these vehicle almost came 10 years ago. Okay, so best examples I can say the BMW i8. So this is the example for the mild hybrid vehicle. Okay, and you can see here I can classifying here the range is provided by the pure electric motor. So what is the size of the battery? So here the range is not provided by the motor, that's why it's mentioned the 0 kilometer. But size of the battery is required because of we are using the battery only during the starting or stopping of the vehicle. So that's why the size of the battery is 1 kilowatt hour. Okay, and the next that we are going to see about the next stage is the hybrid electric vehicle. Okay, which have both an come engine and motor. Further, this vehicle can be classified based on the arrangement of drivetrain, such as serial hybrid, parallel, power split hybrid, and also we can classify it based on the degree of hybridization, such as micro, mild, and full, and a plug-in hybrid electric vehicle. So next you can see here there is a two different plug-in and a range extended electric vehicle. So these two vehicles have the few the some few differences there. First, the range in range extended electric vehicle, it's like we can call as a full hybrid. We have a both an ICE like and the electric motor, but 100% of their propulsion done by the electric motor. Okay, then ICE here, why we are using ICE means ICE here operate as just a generator to charge the battery. Okay, so example we can say the BMW i3 with the range extender. That is the example for this vehicle. Then you can come here like plug-in. So in plug-in electric vehicle also same concept, but there is a few difference. The difference between this full hybrid and plug-in is that full hybrid EV is charged by the regenerative braking. I said regenerative braking, or otherwise we can charge by the engine. While in plug-in hybrid electric vehicle, like we have the enlarged traction battery, is also charged through a power outlet. Like we can charge the battery here from the power outlet or charging station. So that's a major difference between this plug-in electric vehicle and range extended electrical. We can charge this plug-in electric vehicle or a battery can be charged by plugged into an external source of the electric power. Okay, so the next finally we are coming to full battery operated electric vehicle. It's like completely run by the full electric motor and powered by the battery pack. So best examples you can say the Tesla, Nissan Leaf. Okay, so these are all examples for full battery operated electric vehicle. So here you can see that classifications is based on the range provided by the electric motor and size of the battery. So if range will be increased means you can see the size of the battery pack also will be increased. Okay, the next we see about the battery electric vehicle. Okay, so next we see about the battery electric vehicle. So you can see this is the outer picture. This is like we can say the what are all the key components is located, and what are the key, very important key components is there in the battery operated electric vehicle. So there are a lot of key components are there. Okay, so the basic very major important key component is first battery pack. It's a energy storage device. This called as a traction battery pack. Okay, and this battery pack provide the energy to operate the motor. So the motor. Okay, and the next is inverter. So why the inverter is needed means sometimes the motor, maybe we will use the DC motor or AC motor. If you're using the AC motor means we need to provide the inverter. Okay, to convert the DC or AC for a to convert the DC DC to AC for AC motors. Okay, and apart from these things, very important one more study is BMS. Okay, not only BMS, we can call another what are the energy control unit. So these are all coming into the electronic parts. Okay, so BMS is needed to control the operation of the battery pack, to provide the production or a control, and to provide the performance, to enhance the performance of the battery pack. So we can call simply it's a BMS, the heart of the battery pack. Okay, so these are all very important key components, and particularly in this lecture we are going to see about the battery pack and BMS. Okay, so you can see in car we are using the different battery module. So this is battery module, this is one battery module. So this type of battery models, different battery models we are using it. So we can connect that battery models in series and parallel. So each battery module is have a cell monitoring unit. We can call this is also slave BMS. Okay, so each module have it, and after these all the modules will communicate with the master BMS. It's called as a battery management unit. Here mentioned it's so everything in vehicle, all communications through it will happen through the CAN communication. Okay, so all the electronic units. Maybe we can say the all the monitoring units, all the electronic units. It's an energy control unit. Everything it should be communicated through the CAN, and the CAN receiver will provide all the information to the user. So that's a major communication part is accommodated in the electric vehicle. So now we are going to next we see about batteries. So first is we are going to see about the battery pack and BMS. So what are the batteries we are used in electric vehicles? So I already said the started with lead acid. First we use the lead acid. Now also we are using, you can see the internal combustion engine, we are using the lead acid battery. Lead acid battery will provide the power for maybe four-wheeler means it will provide the power for like lighting and AC. So these things we are using the batteries. So first the major advantage is cost and the recycling, but major disadvantage in our India, maybe we can say the lead acid batteries, energy density is less, and environment, weight is very major high drawback in lead acid. And next nickel cadmium, nickel metal hydride. So these are all also these are all we can called as a evaluation of the battery. Okay, first battery started with uh, you can say, you know, everyone knows a Daniel cell, Volta cell. After Volta cell, alkaline cell. So there is some evaluation has happened. After that, we coming into the lead acid. So lead acid, there is a lot of the development is also added. And apart from this lead acid, the nickel cadmium, nickel metal hydride batteries also is, these are all rechargeable batteries. Still, we are using these batteries in portable applications. Maybe you can see in these batteries in your torch light. Somewhere still we are using this type of batteries. So nickel cadmium, its advantage is like a temperature and lifetime, good lifetime, but weight again. And nickel metal hydride, it's good power density, but cost wise and a very important point is self discharge is very high. And after we coming into the point lithium ion battery. So lithium ion battery has a good energy density, good power density, but the drawback is cost. So lithium ion means we can call it's based on the chemistry. What is the cathode material you are using in the lithium ion battery? So based on that, their energy density and power density will be vary. Even not only energy and power, life cycles and their temperature range, everything. Every chemistry have their own specifications. So the major drawback is cost. Why the cost is very high means because of still we are importing the batteries from other countries. Okay, so we have, so we start first we touched in first EVs. So EVs came, and charging point also it's started, and now we are going to touch the battery. Okay, so batteries we don't have a presently facility. I can't say don't have, because of there are we have the, because of the research institutes in our lab and ISRO. So they have the facility to fabricate the lithium ion battery facility is there. And few companies also, okay, yeah, MNC companies also, they are going to invest to develop the self fabrication lithium ion battery self fabrication facility. So in coming years that facility also will be available in our India. Okay, so then once the facilities are successfully come in our India means definitely the cost will come, definitely will be reduced. And one more what we are facing the again one more again what we are going to touch in the point means chemicals. Okay, so batteries came, the next level of thing is chemical. Because of lithium is not available in India, so again we have to import the chemical, lithium chemical from other countries. So these are all due to these concerns. And the based on the chemistry, what is the future technology. And also we can see the under development means we can see the lithium air battery. Not only lithium air battery, we can see the lot of batteries, particularly sodium battery. Because of due to the lithium is not available now, researchers are working on it sodium ion batteries also. Because sodium is available, okay, much available in our India. So we are looking more on to develop the specifications of the sodium ion and to provide the equivalent to the lithium ion battery means it also come into the definitely into the market, and we can use that type of batteries for solar energy storage applications, UPS. So there we can use the sodium ion batteries. So there are a lot of developments are going on now. And the next, the battery technologies, sorry, battery terminologies. So what are the terminologies? So these are all very important terminologies because of if you are purchasing, okay, if you are purchasing on battery, okay, if you are purchasing on lithium ion battery means definitely you know about this data sheet specifications. Okay, I'm not telling you about the customer user wise. I want to tell about the maybe the if you are if you are working in a particular company, if you are the OEM, if you are the battery pack or battery pack developing company, or if you are a BMS developing company, or if you are vehicle company means that particular person definitely knows about this all the specifications, this all the technicalities definitely they needs to know, and they want to check on whether this battery will support our application or not. Okay, so all the specifications will involve. Okay, so first important, internal resistance. So internal resistance is like a very one of the very important uh, like um, feature in the battery. So this is internal resistance only will identify the battery state of health. Okay, because of if you are if basically the cell manufacturer will provide, for example the cell manufacturer will provide one battery. They will do the all the tests and they will mention that definitely this battery will support for you 1,000 cycles. Okay, so if you are testing that battery, testing that battery for 1,000 cycle means how you knows whether it will be support or not. It's based on the internal resistance. So the cell manufacturer what they will mention means you can use basically what is the good health of the battery means you can use up to the 80 percentage of the state of health. Okay, so below than 80 percentage also the battery is good, it's not damaged, we can't call it as it's damaged battery. Its battery is good but it's not support to that application, you can use it for some other low power application, you can use that battery. Okay, but if it is below 80 percentage means it's not recommended to use it for that particular application. So that should be we can easily calculate it based on the internal resistance and capacity also we can here add it. So therefore resistance to the flow of current within the cell. So voltage, so voltage is the it's very important parameter. So when we are choosing the battery, choosing the cell. Okay, so potential difference between the cells, and current is the rate of flow of charge. So current how you can decide means it's based on the C rate. Okay, and next we see about the capacity. So capacity is amount of charge, how much amount of charge we are storing in the battery, it's called as the capacity. And next we see about the specific energy and specific power. So specific energy, specific power, energy density and power density, so these are all will provided, it's based on the electrochemistry wise they will provide these details. Okay, so we have to choose whether my application will require the high energy density or some other application will require the high power. Okay, if for example you can move into the um, um, like space applications, aircraft means, so that type of applications during the ignition it requires the high power. So that particular for that reason we have to choose the battery as a high power density battery, we need to choose it. But some applications it's not require the high power, it require the energy for longer period of operation. So for that application we have to choose the cell as a, it's supported as the high energy density. Okay, so that's a technical words we are using how to choose battery based on energy density and power density. And the next we see about the C rate. C rate I already said how the charge and or discharge current as a proportion of the rated capacity in Ah. So C rate means how much charge or discharge current is from or to the battery we are flowing, it's flowing in the battery. And the constant, these are all types of charging method. Okay, so constant current charge, constant voltage charge, trickle charge. So basically we are using the CCCV charging technique. um, basically we are using the CCCV charging technique, still practically we are using. So this technique will provide the very during CC, there is a two sections are there. One is a CC, another one is a CV. Okay, so once the during CC condition, your current will be constant, the voltage will be increased. So once the voltage will rise to the cutoff voltage, so the current will be going to reduce and voltage will be constant. That is called as a CV. Okay, so this is presently we are using the CCCV charging technique to charge the lithium ion battery. Okay, so these are all the important terminologies. Basically we needs to know technically, technical engineer definitely they needs to know when choosing the cell, these are all the parameters they need to check and verify. After that they need to use it for that particular application. And next we see about the why lithium ion batteries. Okay, so from all the concerns, okay, compared with all the conventional batteries, why we choose lithium ion batteries? The first point I already said, it has the higher energy density comparing with all the batteries, all the conventional batteries. Second, long life cycle. Okay, and maybe if you are maybe that is you can see in the comparing with the lead acid. Definitely lead acid will provide you for they will mention like a maximum 2000 cycle times, means definitely lithium ion battery it will give the 5000 to 6000 cycle range. Okay, I am orally I'm telling it's everything is based on the chemistry, but anyway it should be some higher version than lead acid. And the next, deep discharge. So we can do the deep discharge, but basically it's not recommended for a safety wise. Okay, uh, uh, what is happening means, if you are doing the deep discharge, again if you are charging the battery, means it takes more time to coming into the normal level. Okay, so that's why basically we will give the 80 percentage of the DOD. Okay, we are maintaining that is the standard one in lithium ion battery, 80 percentage DOD in every all the applications we are maintaining. And highly efficient in storing and returning energy, and it has a fast discharge capability is there. And next we see about the flat discharge curve, and very low self discharge. For example, you can store your these batteries for 6 to 7 months also, you can store it, and you can after you can test also, the self discharge is the self definitely will not happen it. Okay, if it be there also is very very low point, not one we can say that. And maintenance free and non toxic, and no disposable problems. So these are all the very why we are using the lithium ion batteries compared with in the conventional batteries. And next we see about battery cell form factors. So what are the cell form factors? Means cylindrical cell, pouch cell, and prismatic cell. So before we classified the batteries.
Yes, ma'am. You can
Yeah.
continue.
So before so last slides we seen about it's a chemistry based things classification we seen, but here we are going to see about the classification. It's based on the form factor, means what are the shape of the, okay, what are the shape of the lithium ion battery we are using in presently. So one is the cylindrical cell, pouch cell, and prismatic cells. Okay, so basically cylindrical cells we can call as a standard size 18650 cell. So this 18650 cell even we are using in here, and even it's very tested. Okay, and presently we are using in lot of application this cylindrical cell. So this particularly this 18650 cell is it's like a proven one. Okay, so there are a lot of the branded companies they are delivering this cell, Samsung, LG, Panasonic, so a lot of companies. And apart from these sizes, uh, there is lot of the present a lot of the sizes is developed for a 26650 cell, 21700 cell, and particularly the Tesla they are using their own size of cell, it's I think 4180 some size they are using. So why the sizes we are increasing means to increase the energy density of the battery, because of for 18650 you can see the market up to the capacity maybe up to 3 Ah. Okay, but if you are moving into 21700 cells, you can see in the market up to 5 Ah to 6 Ah batteries are there. So due to increase the capacity of the battery, the sizes also it's increasing. So it's steel casing and low manufacturing cost, high specific energy, and good mechanical stability. Okay, and specifically we are using in our India this cells in for two-wheeler applications, and portable applications also we are using on it. And next, coming to the point, pouch and prismatic cells. So pouch and prismatic cells, there is no standard size. Okay, so because of each manufacturer have its own design, these because of these cells will be their sizes will vary based on the energy capacity. Okay, maybe you can see in market also these prismatic cells up to 100 Ah also is there. Okay, that's the main difference between the cylindrical and prismatic and pouch cells. Because of cylindrical cell capacity is very low, up to you can see the 6 to 7 Ah maybe you can see it. But prismatic and pouch cells you can see up to 550 Ah, 60 Ah, 100 Ah. So there is a lot of higher capacity cells these are. That's why we are using these cells are in high power applications or high energy requirement applications. We are using these two cells. Okay, and these sizes of cells, they have the each manufacturer have its own IP. Okay, so we can't say this is the standard size, we can't say it. And the pouch cells, it's have a laminated bag, high energy density, requires stacking pressure and sensitive to moisture and high pressure. And this is we are using in four wheelers. Maybe you can say the Chevy Bolt, that type of vehicle, they are using this pouch cell configuration. And prismatic cell we are using in three wheelers. Okay, mainly we are using in three wheelers, and it has aluminum or steel casing. So that is the main difference. That's why due to the aluminum casing, the battery weight also will increase, and a good energy density, and commonly used in electric vehicles. Next, we see about the stages of battery pack design. So once we seen about the battery and different battery form factors, so next stage we are going to see about how to design the battery pack. What are the stages are there? So first stage is cell. First we have to choose the right cell. It's based on the energy, power, and the form factor, whether cylindrical or pouch, prismatic. So this type of configuration, first we have to look on it to choosing the cell for particular application. Okay, and next stage is hello.
So I got a this one letter from so I thought I will take your sign and submit.
Someone else please mute the mic.
Sony ma'am, please mute your mic. Sorry, ma'am, it was accidental. You may continue, ma'am. Hemodi, ma'am, you can continue, ma'am. Hemodi, ma'am. Some network issues with the Hemodi, ma'am. Let's wait for her to rejoin. Ma'am? Hemodi,
Sir,
ma'am?
I'm audible, sir?
Yes, ma'am. You may continue, ma'am.
Yeah, okay. Okay, so the next stage is the cell block. Like we can say the module. So module means we have to connect the cells in series and parallel to build the battery pack for uh, uh, to meet the low demand of application. Okay, so if you are in connecting the cells in series, the voltage will increase. Connecting the cells in parallel, the capacity of the battery pack will increase. So that is the next stage. On third stage we have to frame the pack. So packing of the frame means apart from the cells, we have to add up the like a different like inbuilt BMS, because of sometimes we will use it like a slave BMS. If it is very large system, for example, if we are going to develop the battery pack for a car, so in each car they have a modules. Okay, so after we have to connecting this all the modules, so we have to put the one inbuilt BMS, it's called as a slave BMS, that should be in the stage. And finally the BMS fitment means it's common BMS, like there is a centralized BMS. So all the information, all the module, all the cell module pack, everything, all the information will coming into the centralized BMS or master BMS. And finally we are coming into the packaging, like we can say the final battery system. So one first level is module cell module and pack and system. Okay, so in system you can different configuration of the system as per the customer demand and applications. Okay, so first we need to connect the cell series and parallel, it will provide the module. Okay, then each module, okay, and each module we have to connect it in series with the inbuilt BMS. Sometimes if you require the high energy means again we have to connect the each this is called a pack. Now we have to connect again the module in parallel, number of parallels we have to add it, so it will provide the complete battery system. So where we are using like megawatt level, this type of battery system means basically we are using for the grid energy storage or any backup where we are recurring, particularly for grid energy storage we are using this type of megawatt level megawatt range level storage system. Next, we see about the cell to model. So I already said how we are connecting the cells series and parallel and what is happening in that. If you are connecting the cells series first, for example, if I am connecting the two cells in series, it will increase the voltage of the battery system, but the capacity remains the same. But for example, this voltage, this cell have a 3.6 volt and this cell have also 3.6 volt. If I am adding these two voltages means my output is like, you can say, we can say the 7.2 volt. Okay, but if sometimes this battery, maybe I just provided two batteries, maybe if it is a large string, for example, if I'm connecting the 13 cells in series means approximately all the cell voltage should be, we have to keep it in equal level. If any one of the sum of the voltage will be the very low voltage, for example it will be like a 2 volt or 2 volt means that is called as a weakest cell. So what will happen, this weakest cell will dominate the complete string, and it will damage the complete string in the battery pack. Okay, and the next concern is parallel connection. So parallel connection, here we are connecting the cells in parallel to increase the ampere capacity or to increase the current level of the battery. But when you are connecting the cells in parallel means current only will increase, but voltage should be same. And next, these are all very basic. Okay, because of these are all like uh, okay, so these are all like you can see in your like the basic circuit analysis, maybe you can see these things. And the third thing is series parallel configuration. So here we are connecting cells like we are increasing the both voltage and the capacity of the battery system, it should be increased both. And parallel to series configuration also, whatever we can, first we can connect the cells in series and parallel, or otherwise we can connect the parallel to series. So that is our own design, what we want we can design it. Okay, and the next we see about the cell to module and to pack. Okay, so first level, how we are building the how we are connecting this cell into the next level is module. Okay, so here you are connecting all the cells. Okay, then interfacing the BMS, and the next stage is we are packaging is called as a pack, and we are keep it in particular application. So this is the step by steps stage. And next we see about the aspects of building a battery pack. So here there are different once the battery pack is ready, so what are all aspects we have to concern when we are designing or building the battery pack? Apart from the cells, very important thing is thermal management. So which application, based on the application, what type of thermal management is needed. If, for example, thermal management in EVs is quite complex in comparison with the ICE vehicles, so various techniques can be used to distribute heat very flexibly within the vehicle. Okay, so these are all based on, for example, if very low power application, air cooling is it's sufficient. When you are moving into the high power application, car, four wheelers, like there we have to use it for liquid cooling technique, because of liquid cooling technique has a more heat thermal conductivity compared with air. So therefore it's based on the how much batteries we are using, how much thermal conductivity materials is needed. Based on that we have to choose the uh, thermal management system. And mechanical management is why we needed means sometimes the battery, sometimes some the some accidents will suddenly will happen. The accident, what will happen, first it will crush the vehicle, and after that once the vehicle will crash means it will affect the inside of the battery pack also. So therefore when we are developing, so then the structure also we have to consider it. So EV battery packs are prone to failure uh, due to the continuous transmission and mechanical vibrations and exposure to high impact forces and thermal runaway. So the robust mechanical design and battery packing can provide the great degree of protection. And finally we are coming into the point electrical. So electrical safety precautions for overheating, heat accumulation to be taken care while designing and usage of the battery. Okay, so therefore what is the electrical concern, we have to very important. Electrical means everything. If you are counting the cells in CS, that is also will come into the electrical. And if you are providing some protection devices, fuses, any circuit breakers, some that is also will come under electrical devices. And apart from this, very important and there is major portion you will consider under the electrical is battery management system. Okay, so now we are moving into the battery management system. So why battery management system is needed? Okay, so everyone knows basically battery has a high energy density. Okay, so what will happen? Major concern is what is the high impact of lithium ion battery means thermal runaway, fire. Okay, this is during when basically it will happen means during the mechanical abuse, electrical abuse and thermal abuse. If any one of the abuse will happen means, if you are not controlling that abuse means definitely the battery will finally will leads to the fire fire explosion. Okay, so here you can see the that's why I said mechanical abuse and overcharging, temperature overload, short circuit, low quality of this. So these are all will finally will leads to the thermal runaway. So how to avoid this thermal runaway? So that's why battery management system is needed to control this control the operation of the battery. Okay, and the what is the main function of BMS? First, very important point, safety, production. And it should be monitor or measure the voltage, current, temperature, and estimate the performance of the battery in terms of state of charge and state of health. And sometimes we have to analyze the data. Maybe in future we have to analyze the data means we can do the record service, and the data logging we can use it, we can add up in our extra feature in BMS. And indicate, it's a very important point, it will provide the indication and prevention of hazards, and communicate with the other BMS and energy controller, electronic control units also. And next we see about the production circuit. So what are all, next we see about the features of the BMS, what are all the important features is we are considering when developing the battery pack. So production circuit, the very important features are over voltage and under voltage, overcharge and discharge, over current, overheating and short circuits. So these are all when we have to be considered, we need to include when we are designing the circuit for the in for hardware in hardware development of BMS. So you can see here when first we are adding the um, thermistor. So the thermistor is used to monitoring the temperature of the battery. Okay, and the next you can see the voltage comparator, and the sense resistor used to sensing the current flow through the uh, battery pack. And these are all first the stage it will be, these are all comparator. First it will be compare whether these all the data, okay, all the description or data, it should be within a limit or outside of the limit. So these are all first it will check it, and after that everything should be in within the limit only, it will drive the, or it will turn on the charging and discharging MOSFETs to to start the operation of charging and discharging operations. So that's a major concern here. And the next we see about charge and discharge topologies. So basically in BMS you can see that there are we will use the separate MOSFETs for charging and discharging operations. For example, here you can see the two MOSFETs here is there. So one is for charging operation, another one is for discharging operations. So these two MOSFET drivers should be controlled by the AFE, that is called as analog front end IC. Okay, so we can add up these MOSFETs in high side switching or low side switching. So basically, very for single cell BMS, we can basically add up in low side. But after you can see very high current. For example, it started with the 15 amps, 20 amps, above 20 amps means we can add up the switching in high side. So what is the profile means? If there is no fault means both will be turn on, and if it is any fault, for example under voltage fault is there means charge will be turn on and discharge will be off. If it is over voltage fault means charge will be off and discharge will be turn on, and it should be over current or short circuit fault means both will be turn off. So that's the main charge and discharge switching profile in this BMS. And next we see about the cell balancing. So the main function of the cell balancing circuit is uh, to maintain the all the cell voltages is equal level to enhance the lifetime of the battery pack. That is the main function of the cell balancing. So why it's the requirements to achieve the maximum efficiency of the battery pack, to increase the life cycle of the battery pack, and to protect the battery from getting permanently damaged. So for example, you can see here there are different water levels in the glasses. Okay, so this is we are taking the cell also. For example, this is we are mentioning it's a full the glass is fully okay, it's a full water. We can say like in battery it's like a 100% SOC. Otherwise the battery was in completely fully charged, and this is half of the charge battery and there is no charge. When you are charging the battery, what will happen? Already one battery is fully charged, so what will happen? The cutoff will be happened, it will not charge the remaining cells into the it will not charge the fully the battery in remaining cells. So this is again and again will be happen means definitely the definitely these cells start to degrade it, and it will be provide the permanent damage to the battery pack. So that's why cell balancing is needed. And what are the types? So basically there are two types are there. One is active, another one is passive. So in passive cell balancing, it's we are using the resistor to dissipate the dissipate the energy level in the battery through the resistor. Okay, so basically when due to the resistor, the dissipation is happened due to it's happened through the in the form of the heat. Okay, so that's the main drawback in passive cell balancing. That's why we are using the very low balancing cell balancing current, uh, like uh, uh, to increasing the efficiency of the efficiency level of the BMS. Okay, and also it's very cheaper. It's practically provable, and we are using in up to the two-wheeler application, and the three-wheelers also we are using the passive. And active is basically to transfer the energy from one cell to another cell. So because of we are using the inductor and capacitor, so inductor capacitor basically we can call as it's like a storage device. So it's transfer the energy from one cell to another cell. So due to this inductor capacitor, the cost of the BMS also will increase. So this is very major disadvantage is cost only. It should be very higher cost, nearly 3 to 4 times higher than passive. So what will happen means it will increasing the cost of the overall the battery pack also. So that's the main problem, this active cell balancing. And next, we see about SOC, state of charge, and depth of discharge, and what is the C rate. So C rate we already seen, the rate at which a battery is charged and discharged. And if C rate will increase, means battery life cycle also will reduce it. And SOC is called as it is describe the how much charge is available in the battery. Okay, basically everywhere you can see battery notation. Basically, we will provide it in SOC only. Even even mobile also, how much charge is there, it should be, will get it in the percentage. So that is called as the SOC. So in research level, there are different algorithms we are using to predict the accurate value of the SOC. Okay, there are a lot of techniques are there: direct technique and adaptive technique, and now the advanced techniques are data driven technique. So uh, like how we can increasing the accuracy of this SOC. Okay, and the next, depth of discharge is opposite to SOC. For example, 100% SOC means DOD is 0%. 20% SOC is DOD is 80%. So that's the main difference between SOC and DOD. And DOD will increase means battery life cycle also will decrease. Okay, so these are all the main parameters we are estimating to to monitor the performance of the battery. Okay, and next we see about the BMS topologies. So it's like a centralized, modular, distributed, master slave. So centralized means we are using a only one single controller to connecting the all the three cells through the wires. Only one board only will be there. So all the control, production, and communication, display unit, everything will be there in single board. But modular means the few batteries have a controller unit, and each controller unit will be communicate with each other. Distributed means like each cell have a controller board, and each cell have a controller board, it will communicate with each other, each cell. And master slave means one master controller is connected to the slaves, and the slaves are connected to the cells. Okay, so these two, the centralizer and master slave, practically we are using is for low power centralizer is enough, but for high power application means master slave basically we are using on it. And these are all different applications. It started with the mobile and ended with the grid. Okay, but what is the difference means everything is based on the application requirement. For example, in mobile we are using the single cell, so there is no cell balance is required. So like that, if application requirement, if application like application power requirement will be increased, the BMS features also will be increased on it. Okay, so the final slide, the what we discussed, summarizing the battery design. So first we seen about what are all like mechanical design. Okay, so mechanical design is based on that how to maintain the stability of the battery pack, and how we can do the accurate SOC and SOH, and the production, thermal management, charge and discharge control, and how we can choose the right cells. So these are all when we are choosing, when we are summarizing, when we are developing the battery pack, is all the concerns we have to see seen on it. And these are all our recent developments in our institute. So everything started with cell, and cell, BMS, and pack. So everything our own indigenous product. So thank you.
Thank you, ma'am, for such a wonderful session. Now I request the participants to ask queries.
Hello, madam.
Hello.
It's very nice presentation, sir. Madam, because regarding the batteries and these things, very rarely on Google data available. So it's really very good. Madam, I have one question. That
Yes.
these sodium batteries are we are innovation is going on that. So how much it will be beneficial for this means to replace the lead?
Madam, you are asking about sodium ion battery, how much beneficial in our India.
Ah, ah,
Okay. See, Actually, madam, everything, why this research is everything, why we are making a lot of research in chemistry level means everything for to how we can increasing the energy density and power density of the cell. Because of like our application is, we are looking like our application requirement also it's increasing. Okay, so that's why how we can improvising the cell level. So during that particular point, why we are moving from lithium to sodium means the first point is lithium is not available in our India.
Hmm.
Okay, so anyway, if you have all the facilities in India in upcoming years, all the facilities will coming into the India definitely. But point is, lithium source is not available. So anyway, you have to import from other country. Where it is available, you need to import from the other country.
Hmm.
Okay, so that point definitely the cost will be can't compromise. So
Yes,
because of you are importing the lithium, so
yes,
definitely
yes.
the cost we can't compromise it. Again we will face in cost wise, again we will face the problem in cell level. So that's why the research is going on sodium ion batteries, because of sodium is available, okay,
Hmm.
in
Hmm.
India. So that's why because of C, we have a very large source as a C. Okay, so sodium is lot of sodiums are available in our India. So that's why the more research presently looking on in sodium ion batteries, but still in research level only, not it care. Maybe like the few maybe other countries maybe they developed, and in India also they developing. Okay, R&Ds they are developing, but in market level it's not came still.
Yeah, yeah, yes, yes. One more question, madam. CSR laboratory will work for any means DST project along with us, because as a faculty we want to attach, because there are number of calls from the DST or
Definitely,
as a
madam.
project.
Definitely. That's why I started with my lecture. I said, na, basically, our main vision is to provide the product. Okay, in the field of electrochemical power sources, we have to provide the product to or market into the user in collaboration with industry and academic institutes. Okay,
Hmm.
so
Hmm.
definitely we will support.
Yes.
Maybe you can come up with just you can come up with in official, through official means definitely our scientists will support and
Hmm.
collaborating with you and in the DST projects in all the ways. Yeah.
Thank you, madam. Thank you very much.
One of the participant is asking what is the difference in micro and mild hybrid?
Micro and mild hybrid, there is not a much difference, sir. Like maybe we can say micro, like it should be like whether micro hybrid we can use it for a battery for starting purpose only. Okay, during starting condition only we can use it. Mild also, like we can apart from the starting, like during starting acceleration or like start not only starting. So sometimes the starting and stopping operation, apart from these things, sometimes what will happen, we will give the more acceleration in our vehicle during uh, uh, in our driving. Okay, so that particular time this mild vehicles will provide the support. That's a main difference between the micro and mild. So somewhat the higher version of uh, mild.
Good afternoon, ma'am.
Yes, good afternoon.
Ma'am, my question is in BMS topology, where we use modular and distributed topology.
Um, Sir, I already said na, like there is four topologies. The topologies
G
are
G.
there.
Yeah, yeah,
Basically, practically, we are using centralized topology, master slave topology. Okay,
yeah,
and this modular and distributor also we can use it. Okay, but problem is
G.
some of them we are using, but what why practically it's not recommendable means it will increase the maybe we can say the weight also. For example, if you are using the
Yeah,
if in for example I have I need a one battery pack for my two wheeler. So in that battery pack there are nearly multiple cells, or maybe more than 100 cells are there. Okay,
Yes.
if you are
Yeah.
using each cell for each if you are using for each cell BMS means that is my battery control unit means you have to use 100 BMS you needed for in that battery pack. Okay, so that's why
Okay.
it's not recommended to use the centralized BMS. Because
Oh,
of it will increase the electronic part also increase. If electronic part also will increase means that you have to provide more you need to concern about more temperature also, because of electronic part also will provide some amount of temperature.
Okay.
Okay,
Okay.
so there are a lot of concerns are that, that's why distributed BMS is not recommended. But in case we can call it as a, if you are using if your particular application, if you are using only one cell means we can call that BMS as distributed BMS. Okay.
Okay, ma'am. Thank you.
Any other queries from participants' side? Ma'am, Selvam Sedupati sir is asking that he is doing his research work in battery management system. And is it possible for him to test his pack over your lab?
Definitely, sir. You just mail me. Okay, my email ID I already shared in my slide. Just mail me what's your requirement and what are all tests you want to do in our lab. Just mail with me, and I will check whether what are the facilities we have, what in what kind we can support it. Definitely.
Okay, ma'am. Now I request some of the participants to come forward and give you feedback regarding the session. Dr. Arun Kumar, sir. Dr. Arun Kumar, sir. I think some net issues might be there. Girish Kumar, sir. Girish Kumar, sir. Akshay Jain, sir. Akshay Jain, sir. Can you please give a feedback for Hemodi, ma'am?
hello, I will give her.
Yes, ma'am.
Yeah,
Yes.
I'm here.
Yes.
Sir, it is very nice presentation and it's really very informative and really regarding the batteries and all, this information is helpful for us for innovation and research point of view also. And I'm following the battery management and all these systems. And rarely there are women who knows this much details. And Himawati madam is really having so deep knowledge about it. It's very much impressed me, sir. So I'm very much thankful, sir, that she will be here and I will madam's lecture. Thank you.
Thank you, Asha, ma'am. Thank you.
Thank you, ma'am.
Thank you, Hemodi, ma'am, for giving us a very informative session about battery management system. In fact, we can say that we all are completely charged with your session now. Thank you, ma'am. Thanks a lot for being
Thank
with us.
thank you, sir. Thank you.
Ma'am, one more thing, Hemodi, ma'am.
Yes, sir.
Is it possible for you to share your slides with us? Because many participants are asking for it.
Basically, we will not share the slides, sir. Maybe if recording is there, na, sir.
Yeah,
Maybe we will
recording is there,
just
recording. But still, many
just
participants have. That's why I asked you directly. Otherwise, the
uh,
participants will be asking me continuously for the
yeah.
slides.
So because of through our institute, they will not
I know,
allow
I know, I know, I
to
know.
share the slides. Anyway, I
Yes,
will try my best. Yeah.
yes, ma'am. Okay.
Yeah.
Thank you, ma'am.
Thank you, sir. Thank you
Yes.
very much.
Yes, dear participants, we are breaking now for the lunch, and I'm requesting all of you to resume by 2 o'clock for the wonderful session, which is upcoming one from Sajin Ismail. Sajin Ismail has done his first session in our first session during 9 p.m., 9 a.m. to 11:15, and he will be conducting his session, a second session from 2 p.m. to 4 p.m. Requesting all participants to revert back at 2 p.m. itself. Thank you.
Thank you, sir.
Yes, attendance link is shared for this session in the Google chat, Gmeet chat room. Attendance link is shared. All are requested to mark the attendance. I'm sharing it once again. Okay, thank you. See you soon.